the very least be able to draw PDF of normal distribution with parameter mu and sigma. Okay. Now, the exam platform that July has adopted allows you to actually draw a picture. Okay. So some of the exam, maybe midterm or whatever, you would be asked to draw using whatever paint, whatever, and submit. Okay. You can draw this, right? Normal distribution has two parameters. It's centered around mu and it has a slope. So let's look at the normal distribution, the Wikipedia page. Now, the way I tell people is this. You guys know Napoleon, right? Napoleon has this kind of hat. Well, the center of the head is mu. And around where his temple is, where Napoleon's temple, where the hat kind of like goes down to touch his head, that is where you draw the lambda. Sigma. Okay? So it would look like this. Hold on. So this is a mu. And this here is sigma. Right? This is Napoleon's head. Okay? So draw Napoleon's head. The center is at mu, and where this temple, this part that touches his head here, is sigma, and this is also sigma. Okay. So sigma makes the eye. Okay, very easy. So that's how you draw Napoleon. So that's mu plus sigma, mu minus sigma. That's 2 sigma. By the way, we talk about 6 sigma quality control. That's like probability of error way so small. That's called 6 sigma. So that's it, right? So at the very least, okay, draw this. Okay. Now, so 7, note that mathematical function PDF. By the way, if I don't want PDF, I can do CDF, right? Let's go back to here. Okay. And again, you can make it choice. What to plot? What to plot is either CDF or PDF. PDF or CDF. Right? Okay. Okay, so read all this at your free time. Now, so you can see that, okay, random variance is another thing. Random variance is another thing. Whatever. So now, I want each one of you as class exercise to do something like this. But why use exponential distribution? So let's go to the name of distribution in Mathematica, right? So let's say exponential distribution 1, right? Now, obviously, this is only 1, right? It's going to say, there are many other distributions. Okay. In fact, there's tutorial, continuous distribution. Okay. And this will definitely cover everything. Now, the parameter will have different kind of meaning. So for example, you just go to some silly distribution you've never seen. I don't know what this is, okay? I have no idea. Let's say non-central ratio distribution. I click onto it. Okay, it has 3 parameters. Okay, M is the degree of freedom, N is, so get an example, blah blah blah. So for example, there. So what you want to do is take this. Okay, now this evaluate here. Just copy what it says, okay? Just copy what it says. Okay, and go to your own thing. Go to your own thing. Let's make my own thing here, right? Now, in this case, it's plotting a table of value. I don't want to plot a table of value. I just want individual value. So instead of making a table, I take this out. Okay, and take this out. Okay. So I want to plot this. Okay. And now, guess what? This becomes your manipulate. Okay. First of all, I can do this. But now I take this out and I take this manipulate. Okay. Now, obviously, it's not that interesting because here they go 0.5, 5, and 10, right? That's like a special case. Remember I told you that manipulate. Oops. Oh, I have too many brackets. Okay. So that would be like what your friend was showing earlier, right? But I don't want to do that. So I take this, say 0.5, go up to 10 instead of 0.5. Yeah. Now, I don't want to, so I can do this, or I don't want to know, I don't want to plot. I don't want to plot. Okay. I just want to have the value. Can I do that? Well, okay. That's the value. This is actually the calculation being done. So if I want to get the value, I have to say something like, okay, so that's quite complicated, but you don't need to know that. It's better to look at this. But recall that at the beginning of the class, you will be sending your friend function. Okay. So this is what, you don't know what it is even, but at least you know how to use it. That's no good. I don't want you to do that.
Wait, can you stay on that screen?
I
but
think
never mind.
Erase that. I can start a whole.
It's okay. It's okay.
The last time I did this as well, I keep forgetting that you guys not only see it, you want to have it as a copy. Sorry about that. But anyway, you can start this from scratch. So follow the example here. Okay. Now, I want to show you something else. We're going to actually have to start moving to linear algebra and calculus. But I just want you to show you, just to finish things up. You remember this thing, this data set? Okay. Guess what happened when you ask Mathematica to find? Okay. It turns out that there aren't this kind of mathematical function that does this very nicely. But you can imagine that, let's separate the random distribution into two processes. There is this distribution, there's also this distribution, and then there is a Bernoulli choice. In other words, you have, okay, you have some kind of, let me write this down. Okay, you done? Let me write this down here so you can have it. Okay. Note the O phase full duration here. It has two humps. Okay, what we call multimodal distribution. Okay. There are many. Now, in fact, I can say that none of the above, well, not none, most of the above distribution, okay, 10 to 12 basic distribution, cannot give you multi terms. Okay, I should make it a pop quiz. If this were like a class, I give you a pop quiz. There's one, by the way. Okay, extra credit for finding. Among here, there's one of them that allows you to have a multimodal. Okay, bimodal, 2 more, not 3. 2 is difficult already. Now, however, you can create 2 humps from what's called mixture of 2 single hump distribution. Okay. Okay. So first, perform Bernoulli coin toss. Okay. First, Bernoulli coin toss. If head, use 1 distribution. If tail, use 2nd. Does that make sense? Okay. How would that look like? How would that look like? Well, it's very easy. Okay. Let's say we have PDF. Okay, let's plot PDF of normal distribution. Okay, normal with mean 5, with mean say 1 and 0, 1, 1. Yes. Let's make it 0, 1 first. Okay. Yeah. X from -3 to 3. Okay. Let's do that, right? Now, I'm going to plot two of them. Okay. So what I do is I plot two of them on top of one another. That's not good. Okay. What if I shift this to the right? I'm going to shift this to the right. Let's say 3. Okay. Right. So now there are two distribution, right? Let's adjust a little bit. Okay. So it doesn't look the same. Okay. Now what I can do is make a Bernoulli choice. Well, what's a Bernoulli choice? It's just a linear combination of this and that. So let's say that I want P is equal to 0.2 is equal to the probability of the left distribution. And then, so that P, 1 minus P, okay, equal to 0.8 probability of right distribution. Okay, how do I do that? Well, instead of making them separate functions, I just make them same function, right? 0.2 plus 0.8. See? Now, let me add this range, plot range. Oh. Okay, now I'm going to control the mixture, right? This is not so much fun, is it? This is not so much fun. So I'm going to control the mixture. So I'm going to manipulate.
Professor, could you slow down?
Oh, sorry. Okay, so you saw that I could plot two PDF, right? To Napoleon hat. Now I want linear combination of Napoleon hat, the weighted sum. So I take 0.2 of the first hat plus 0.8 of the second half. Right? So let me write them on a separate line so maybe it's easier to see. Right? Okay, you guys with me so far? So I'm gonna take, so this is Napoleon hat. This is another Napoleon hat. It's smaller head, pointier to the right. I want to combine them. So I just take 0.2 of this and 0.8 of that. Because I did this, and 0.2 plus 0.8 is equal to 1. I'm guaranteed that the area underneath is also 1. So it's still a value. This is called a mixture. Now, in theory, you could have 3, but once you can do 2, you can do 3. Okay? So now, do this. Now what? Now, what if I want to change the balance? Well, I just turn this into alpha. Escape, A-L-P-H-A, escape. Okay? And this one is 1 minus alpha. Who's stopping me? Nobody's stopping me, right? And then I put manipulate and comma, I manipulate alpha. Okay, alpha going from 0 to 1. Okay, start from 0. Right now, by the way, a nice trick again for your application demonstration. Let's say the more interesting case is 0.5. You can add like beginning value here, put in a bracket. Alpha starting with 5, 50%. Okay, so start here in the middle. Okay, let's say or say start at 2. Okay, but you can still move it. This is called mixture distribution. It's one of the most powerful tools because it allows you to fit real data that are really silly, funny looking things. Okay, let's see if Mathematica does this for you.
Excuse me, ครับอาจารย์ can you please show us that again?
This one.
Like, just 1 second.
1 distribution, 2 distribution, alpha, 1 minus alpha.
Thank you, ครับอาจารย์
Okay,ครับ. Now, once we have that, let's see if Mathematica does this as well for the old Geyser data.
อาจารย์ครับ excuse me ครับ so for alpha is it just a constant or does it mean anything?
It's giving the, okay, remember, okay, let's go to this picture. The old Geyser, yeah. This old Geyser, right? Now, let's say that in terms of physical geography, right? There are 2 cavities underneath the earth. One is a smaller one that fills up, explodes for about 2 minutes. Then there's a big cavity that is larger, and when it explodes, it lasts around 4.5 minutes. Okay, and at any given point, if the left one fills first, it would explode first. And then if the right one fills, it would explode. Okay, but there's also a relative probability of the small cavity versus big cavity. So let's say that this area here is 0.4, 40%. This area here is 0.6, 60%. That means that the eruption comes from the small cavity 40% of the time, comes from the big cavity 60% of the time. So that would be a 40-60% split, right? Now, if in the future something changes so that the relative probability changes, maybe the small cavity would explode more often. So that alpha is the relative probability between 2 cavities. Okay, basically what it does is it either makes this thing big, this thing small, or makes this thing small, make this thing big. Now, in reality, you have to fit that to the data. In this program that I made up just now, okay, that would be something like, okay, so this is like small cavity all the time. This is big cavity all the time. This is kind of 50-50. This is small cavity all the time. Okay. So you can adjust this parameter. So it becomes another parameter. Okay. So in your statistical class, you only get to fit 1, right? Right? So you can't fit something like this. So I'm saying if you can fit 1 and you can fit another one separately and you can balance the weight between them, you can fit funny shape like this. Let's see if Mathematica is smart enough to do that. So let's find distribution. Let's find distribution of this Old Faithful distribution. See, it's actually giving you this mixture distribution of normal distribution and log normal distribution. Okay, you haven't learned log normal distribution yet. Okay, I'm going to copy this, by the way. I'm going to copy this and I'm going to plot. Okay, but in fact, I did it already. Here. See? So this here is the data. This here is the fit. It's actually combining two things. It's combining 35%. Can you see the number here? It's giving 35% to log normal distribution. Okay, and 64% to normal distribution. And the log normal distribution has mean of 0.7. So it's actually very short burst. So this becomes the data fit. Now, what I did before was use the empirical, but in this case, I'm actually using this. Okay. So this is what we mean by parametric estimation. Parametric estimation. Where's the word? Where's the word? Where's the word? Parametric estimation. Okay. So in the end, you have two sets of parameters. One for first, one for second distribution. Mix plus another mixing parameter, i.e. alpha, between 0, 0, 1. Okay, so if it's 0, then it's all second one. If it's 1, then it's all first one. If it's 50-50, then it's between. So this just increase more parameters, but you can do it. You can do it. Okay. Now, what I'm going to do, is start on calculus review, if I may, unless you want to go on. Actually, it's worth it to go a little bit more. So I might as well go on to multivariate. So this is what happened. Okay, all this happens here. Where's my Wikipedia page? Okay, it's my list. Oops. Okay, so this is my list. Let me just show this here. Again, discrete versus continuous. By the way, let me make a little note. Where's discrete versus? Recall. Okay, let me make this 0.6. Recall that with discrete distribution, we work with PMF and CDF. And with continuous distribution, you work with PDF. For Mathematica, you use function PDF for both PMF and P. Okay, of course. Okay, you guys remember this, right? PMF stands for probability mass function because probability is at the discrete point. Okay, so it looks like probability at discrete point. Okay, whereas continuous, it's sort of like some kind of curve. Okay. Now in this case, this is sum of P, D, F. Oops. In this case, this is integrate under the PDF curve. Right? So the CDF for PMF, in other words, for discrete, it's going to be like a staircase, right? Keep adding probability. But the CDF for continuous is going to be a curve. Start from 0, finish at 1. Okay, this is all review. So let me go there. Now, amongst the now, what I'm going to do here is start on these guys. So we have about 40 minutes. Okay, so we don't have much. So let's go. Let's go linear. Okay, so I'm going to start with number 1 here. Number 1. What do you mean by linear? Guys? Well, if you look at here, now this is something you don't understand at first, right? Linear comes from the word line. Okay? What do you mean by linear? Well, linear comes from the word line. Linear in so you observe linear trend if you see constant proportional changes. Okay, that's what you mean. Now, another word, if it takes one person an hour to do the job, okay. If it takes you an hour to give a haircut to one person, it takes you 2 hours to give haircut to 2 persons. If it takes you 3 hours to give haircut to 3 persons, right? So it's proportional. So basically an hour per head. Yeah, that's proportionality. That's the sort of sense we're talking about. Now, is that the case? No. In reality, it will be different, right? It may be that you haven't cut hair for a while, so the first head of hair takes you an hour. The second one takes you 40 minutes. The third one, you become quicker, 30 minutes. The fourth one, you're tired. It actually goes back to 40 minutes. Okay? So that's kind of non-linear. Yeah, so that's a set. But technically, linear transformation, okay, means that transformation AX plus BY is equal to A T of X plus B TY. Technically, okay? Now, this is where I want you to pay attention, even if you've done really well in high school in linear algebra. My question is, let me ask, is function 3x plus 2 a linear? Who thinks yes, who thinks no? Okay, well, let's make it easy, right? So, does A, okay, let's say T of, okay, my function, my F, okay, my F of X is equal to 3x plus 2. Okay, my question is F, my F of AX plus BY equal to A of my F X plus B times my F Y. Anybody think it's true? Raise your hand. No, it's not. In fact, if you simplify, okay, take any number. I don't care what number you have. Okay, you will see that. Okay, let's say simplify. See, this is 2a, right? Right? 2a, 3ax. So we have 3ax. We have 3by, but you add 2b into a, and this 2, where's 2? They're actually different things. So, funny enough, y is equal to 3x plus 2 is not a linear transformation. Okay? Y equal to f of x, 3m, say, ax plus b is not a linear. Okay? It is affine. Now, go find out why. Go find out why. Weird, right? You all your life, right? All your life, you look at this and say, that's my linear equation. It's not. It's not. It actually isn't, right? Oh, weird. Anyway, so I'm going to leave that as a puzzle. Okay? Let's go to the concept. Linear means what? So let's go to, what does it mean, linearity? Linearity is this condition. So the point here is, you are going to learn linear algebra. Okay? You're not going to learn affine algebra. So linear algebra means you are learning the general meaning of something that satisfies something T. That is right. Okay, just keep this in mind. Let's keep this in mind. Okay. Now, in particular, for the rest of this class, X and Y will be in the form of vectors. Okay, in this class, A and B will be in the form of scalar. Okay, and finally, and this is the big reveal. Okay, T of X will be in the form of matrix multiplication A. Okay, the matrix A represent linear transformation. Now, this is all the abstract thought I want to follow. That's it. That's all. Okay? Linear algebra means you studying something that satisfies this property. That property means, okay? Think of production process, where if you add or multiply input first, it's the same as adding or multiplying by a scalar. Okay, multiplying if you add or multiply by a number, input right? So you add two ingredients, or you double the ingredient, and you produce it. It's the same. You get the same output as production process followed by adding or multiplying. Okay, so you double the input, you get double the output. Okay, you get the input on A, you get something. You get input on B, you get something. If you get A and B as input, it's the same thing as getting the A to the output, getting B to the output, and adding them together. Okay, and this happens in a lot of, say, mixing. Okay, it's a bit, okay. So something like, but not always mixing. So if you think about it, if you take apples and orange, and you cut apples in half, put in a plate, cut orange in half, put in a plate, and you put them together, or you put apples and orange together in a plate and cut each in half, it's the same thing. It's the same thing, right? Because apples and orange are kind of like just kind of additive. That's what it means. Not always. Not always. You can't take egg white, fry it, egg yolk, fry it, and put them together. It's not the same thing as putting egg white and egg yolk together and fry it. Okay? So frying an egg is not a linear transformation. But for the rest of the class, x will be in the form of vectors. Okay? So let's look at what we do. Okay. So first, I want you to look at this from a very abstract way. I want to say x. Okay. Oops. Okay. X is equal to, say, array.
Can you scroll up so I can see your simplified codes?
This one?
Not that one, like the Mathematica.
Oh, Mathematica, okay.
Yeah.
Yeah.
I just want you to scroll up. Thank you.
I have a question.
ครับผม
What is the difference between array and list?
Array and list. Okay. Array is a function. Okay. Let me write. Okay, that's a good point. Let me write this here. Okay. Oops. First of all, in any kind of programming, you have what's called data. Yeah. Built-in data type or data structure or yeah. Now, Mathematica, like Python, the most important thing is a list. Type. Yeah. This is the most important. Now, in Python, I think you use this square bracket, but in Mathematica, you use something like this. Right? So on. Okay? It's the most important. Okay? An array, side note, array is a function that creates a list. Okay? Table, arrays, etc. are built-in functions that create a list. Okay, so if you go to here, you see that an array, okay, an array creates something followed by this. Now, because I have to clear X first. Sorry, I have to clear X. If I do this, okay, X vector dimension 10 is equal to what it does. It just creates this with different index. So if I'm going to take this and I take the third element, now I don't have any value to it yet. It's just going to give you this. Okay, a table would give you the same thing, right? So x vector, well, let's say, so this is an array of x. So let's say a table, what would the table look like? Well, table, if I use the same function, what's going to happen with table?
Can you scroll up a little bit? I
Okay,
just want to see the starter of the function.
Oh, okay, let's just use this. Okay.
Like, can you scroll up a little bit? Yeah, thank you. Thank you so much.
Oh, this was from earlier, way earlier. Okay. So an array is just going to make a list of 10 objects with an index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to create this. Now, whereas if I make table, it's just going to make x 10 times, right? Right? Now, if I want to make the table like an array, what I have to do is define it differently, like x of I, okay, and then I from to 10. Now it's the same. Okay, so these are different placeholder. These are different way of dealing with a list of number. So first of all, to create a list. Okay. Side note. One reason is that you can use list of n elements to represent vector of n dimensional vector. This is n number. Okay. Now, in Mathematica, it's both general and specific. If I write something like this, 1, 2, cat, dog, right? This is not a vector, right? It's a list of things. Okay. I can't do this. I can't do something like 3 multiplied by that. Well, you can, just symbolically. It's assuming that this is a number or something. Okay, it doesn't really make sense. Maybe it does, I don't know. Okay, but if it is a number, then it makes sense. It makes mathematical sense, right? So what we are going to do is the fundamental object is we are going to use this as vector of 4 dimensions. Okay, now be very careful, because when you look up in linear algebra book, you don't write it this way, right? Again, mathematics versus programming. So mathematics gives you a way of format. So let's format, okay, as a matrix form of this thing. Now it looks like a vector. Okay, so don't be afraid to write the final report. You know how you're gonna put the first line, the second line. You use this. You just write it first. You worry about the number, and then you just write in matrix form. Okay. Now matrix form doesn't mean that this thing is a matrix, because this thing is a vector. Matrix in this case means matrix algebra. It covers everything from matrix. Okay. So let's go to this hierarchy. We call number is a scalar. A column of numbers of fixed length is a vector. A rectangular table or array. Now this is not the name of the function. This is an English word, array. Sometimes use the word array. Of fixed number of row and fixed number of column for fixed length n is a vector of now let's say the fixed number of row m and fixed number of column n is a matrix of dimension m by n. Okay. Into this. Okay. Right. So i.e. think of a table right? What about this? What about a stack of rectangle table is a tensor. Now, or the computer screen, TV screen, right? What's the normal? What's my resolution? I forgot. Most popular screen resolution. 2011. Okay. 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 Right. Now, I think what this means is it has, this is the width, this is the column. Okay. Is now watch this, watch carefully. It's 19,000 times 1,000, right? It's almost twice, but it's twice as wide. But in our case, what would you say it is? What would you say it is? It's a 1080 because that's the number of rows by 1920 meters. Okay. On there. Now, you probably don't see this, but it's called black and white of brightness. Okay. Now, stack of table or think of now, we don't call it black and white, right? We call it RGB. Okay. Okay, so this is the hierarchy of what we're talking about. Okay, so here again in linear algebra, it's abstract. Okay, it's this kind of process. So the reason I want you to know this is because in life, okay, in your data analytics, because linear transformation are easy to work with, a lot of people will use that to model the data. But it only makes sense if your data comes from this kind of mixing process. If your data comes from some other process, linear transformation will not work. Okay? So that's the first thing you need to know. Second, you need to know that in our class, we are going to be working on data. In particular, we spend a lot of time on numerical data, a lot of time on numerical data in the form of table, like height, weight, age of your clients. Those are lists of numbers, and therefore the most common, most basic form of things to work with will be vector. But vector is just this kind of structure. Below it, there is scalar. Above vector, there is matrix. And above matrix, there is tensor. Okay, this thing. So if you think of numerical attribute of your client as a vector, then you can think of numerical attribute of one client, of m client, n numerical attributes as a vector. Sorry, m. Okay, let's think of Excel. Let's think of Excel. Okay, let's think of Excel. Let's say you have n, and you have m clients as an m by n matrix, right? Because you have m clients, each of them has n attributes. Okay. So therefore, a vector and how we manipulate vector with matrix multiplication will be central to data analytics. Yeah, doesn't have to be big, small. Okay. So that's where we are. So today, okay, now what I want to do is for next class, literally go into the deeper meaning of this. But before I go, okay, I want to go over the basic operation, and this is something I want you to be able to have. In fact, I gave you the list, the table. Oops. You guys have my mathematical notebook, correct? So read ahead to know that. Well, first of all, let's do the matrix multiplication. Okay, let's not finish it. Hold on. I can't stop yet. Okay, 6. Okay. How to manipulate vector. 1 Okay, you can multiply it by a scalar. Okay, 2. Okay, so let's say I have a matrix. I have this matrix, right? So this is my vector is equal to this. It's equal to say 1, 2, 4, 2. Okay, it's my vector. I can multiply it by anything. Alpha minus vector. Right? Right? So let's say my other vector is equal to 3, 5, 7. Okay. Now let's see what happened when I try to do this. My vector plus my other vector. Doesn't work. Doesn't work. Why? Because my vector has 4 numbers. My other vector has 3 numbers. Okay, you can't mix them together because they don't match. Now you're thinking ahead. I think a few of you are thinking ahead and say, wait a minute, maybe you collect data, height, weight, and age of your clients, but the age is missing. That is not the same as having 2 dimensions. You still have 3 dimensions, but you have missing data. It would be something like, this is my, okay, my client 1 is equal to 34 years old, okay, and 75 kilogram and 168 centimeters. Okay, my client number 2 is, I don't know the age. I know that this person is 57 kilogram and 152. You can do this, okay? This is not the same thing as this, okay? These 2 are different kind of animals. This animal has 3 attributes. This animal has 2 attributes. This animal has 3 attributes. You just happen to not have the information. Okay? Now let's say you have. Okay?
Can you scroll up? Thank you.
Okay.
Will you be sharing this one with us?
Sure, if I don't forget to.
Please don't delete this one.
Please don't delete this. Okay. Okay, Cap. So I can't do this, right? So it's like different kind of animal. But this you can do. So what can you do? You can say, if I have 2 of my client 1, I can do that. I can set my client 1 minus 3, my client 2. This is all valid, right? It's just a number. Okay. So what can you do with a vector? You can multiply with a scalar. Okay. You can add, subtract it by another vector of the same dimension. Okay, you can do that, right? Now, what can you do? This is a tricky bit. You can perform dot product with a row vector also same. Now, mathematically, now I put the word row here. I'll put the word row here because this is how you do it mathematically, okay? We have this thing, say 3. This thing. Okay. You take this one, you multiply by that one. You take this one, you multiply by that one. You take this one, you multiply by that one. Now, because this vector looks like this vector is like this. So this is called the row vector. This is called the column vector. So column vector is by default, okay? Row vector looks like this. Row vector would look like okay, horizontal. So technically in mathematics, you can only do this. Okay, mathematics, you can do this. So it is like some product in matrix, in spreadsheet. So let's go to spreadsheet. Okay, I can do this, right? Let's say and 0, 4, and I can do some product. Okay. Now you cannot do this with matrix with dot product. So let me do this again. I put transpose here. Can you see that? So this is the same thing, right? This one and this one, take this, multiply by that, this multiply by that. That's like the product between column vector. Well, this one is my column vector. This is my row vector. I want this multiplied by that, this multiplied by that, this multiplied by that. I would use equal to matrix multiply this guy and this guy. Okay, so it's the same thing. It's the same thing, right? But technically, this sum product, take this, make it stand up, whatever. Okay. So you see that this thing multiplied by that thing is that thing. Why do we do it this way? Anybody? Why do we do it this way? If you think about it, what you want to do is this is representing something about your client. Okay? Okay. So let's say your client, right? Your client has three things. Okay? Has so this could be something like has this many. Well, I'll just give example later. But let's say this person has six items of something, 7 items of something, 9 items of something, and 6 items of something else. And this is the price. So these two are kind of different information, right? By stacking like this, it's sort of like giving the same thing. Like this is one person, this is another person. No. This is actually like I want to multiply separately. So this could be 6 iPhone. I don't know, six iPhone at 54 something price. This could be 7 computer at 27 something price. So you want to do this. So this is called a dot product. This is called a dot product. So I want you to know this. This is it. This is the most basic thing you can do. Now, watch this. In Mathematica, okay, if I have something like ABC, okay, and I want to do the dot product, I can do this. Okay, it's as if you have this thing. Okay, and It's like this. It's like you have A as a row, A times E plus B times F plus C times G. It's like that, okay? But in programming, you know, this would take, if you work with vector of 100, it would take forever, right? So what they do is just this, dot. Now notice the difference between this and multiplication. When I put blank, right? Blank is the same as multiplication, right? 5 blank 7 is equal to 35, right? So what do you think happened when I make the left-hand side a vector and the right-hand side a vector? It's going to pretend that you are doing list. Now it's not doing it as a mathematical object, It's treating it as a list. So you multiply A by E, B by, okay? So this becomes element by element. Okay, this is not mathematical operation. This is like a list programming, a list operation. But definitely if you do this, it's interpreting as a mathematical. Now, the most obvious thing we can have is something like this. My investment portfolio is equal to, I have 10% in cash and 30%, 40% in bond and 0.5% in equity. Okay. And market return is equal to, okay, is equal to say 0.01 or 1%. Now let's say bond gives you a 0.02%, 5%, 3%. And for this period, happens to be that equity market loss minus 0.02. So my question is, what is my return? My return is equal to market return dot my investment. Okay, so I actually gain 0.3%. Why? Because I make 1% from 10% of my investment. I make 3% from 40% of my investment, but I lost 2% in 50% of my investment. So this times that plus this times that plus this times that is equal to this. For the period, I make 0.3%. Okay, barely above 0. This is the main way of using it. Now, how would this work with us? How would we need to work with this? Well, obviously, you guys remember this, right? Linear regression. Y is equal to A0 plus A1 x1 plus A2 x2 plus A3 x3, right? Right? When what we want to do is to say my explanation independent variable is equal to 1, x1, x2, x3. Okay? My regression coefficient is equal to AO, A1, A2, A3. Okay? Y is equal to my regress coefficient dot my independent variable. Okay? This is how you would do linear regression, right? Y is a coefficient times, so this is explanation, so this is constant, explanation variable number 1, 2, 3. So this is it. This is how you model. And machine learning, okay, if you don't know anything better, think of machine learning as a very, 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 very fancy regression. So that's why this kind of dot product is something you want to be comfortable with from day one. Okay. So in this case, my model is represented by this. Finally, let's go to a vector. Well, you can perform matrix multiplication with a matrix. So think of it this way. If I have this, right? This is my row vector. This is my column vector. Now, let's say I add another one below this. Okay. I take the result of the first and add them. I put it over here. I take the second row operation with the same thing. I get over here. Right? Notice, what is this? This is now a 2 by 3 matrix. Right? What's this? This is a vector. A vector is a 3 by 1 matrix. And what is this? This is 2 by 1. So this is the basic of matrix multiplication. Okay. Now, let's look at what we can do with this. So let's say my matrix, my x vector is equal to x1, x2. Okay. A matrix now, what's a matrix? I'm going to say A and B. And then below that, I'm going to put C and D. Okay, and put them together. Okay. Now, if you don't, if you want to look at what it would look like in a textbook, you put in table form. Okay. Sorry, matrix form. Right? Table form is like matrix form, but not, it doesn't have this nice thing. Okay, how about matrix form? A matrix. Right? It's this guy. So basically what I want to do is this. A times x1 plus b times x2. Put it over here. C times x1 plus d times x2. Put it over here. Okay. Now watch. What I'm going to do is matrix form of A matrix dot x vector. See? A x1 plus b x2. Put it on top. This is one number. C x1 plus d x2. This is another number.
Professor, when I put like the dot product symbol, like the dot, it doesn't do anything.
Really? Are you sure?
Yeah, it doesn't. I don't know why mine doesn't.
Let's just slowly key with me, okay? Open bracket. Okay, A, comma, B, close bracket, dot, not comma, dot, X.
Just a normal dot, right?
Yeah, normal dot. Oops. Okay. I keep using the symbol Right?
Professor, what is clear all mean?
Oh, because I did earlier, I did assign. Remember the first symbol you learned is assignment. I made the assignment. So when I use it again, instead of giving generic y, I want generic y. Okay. Clear. Same thing as clear. Okay. Clear all. It's a bit more plural. Okay. So clear the value. So now if I make y is equal to 5. Yeah, notice y turns black. If I don't type in clear y and I do this, yeah, it's going to substitute 6 for y because it already knew y is equal to 6, right? But if I clear y, shift enter, y becomes blue again. So when I put it here, generic y. So I haven't made any assignment. So I can make an assignment, I can remove that assignment. Just because I like to use x and y all the time, so I have to remind myself. Okay. So this is how, so we don't need this. Let me clean up some of that. Now, what is important? What's important? What's important, guys? Well, I'll show you what's important. What's important is that watch this line carefully. T will be in the form of matrix multiplication. So I maintain that. Recall that in linear algebra, okay, linear transformation is represented by matrix multiplication. Therefore, you will notice, okay, if A and B are scalar, X, Y are vector, of dimension n, each one, both of them. Okay. Then,
excuse me ครับอาจารย์
ครับผม
so when exactly will the class end ครับ I have to go run errands with my mom.
Oh, okay. Tell them 5 minutes.
โอเคครับ thank you ครับ
So if A and B are scalar and X, then what you want is T A X plus B Y equal to A T X plus B T Y, right? You want to do this using A matrix. Well, it turns out that then A is a matrix dimension n by n. Yeah. The first dimension doesn't have to be the same. So let's say m by n. Yeah. Then i.e. A of ax, a dot ax plus by is equal to a dot x plus b. Okay, see if this is true. Okay, see if this is true. Well, I've got my a here, I've got x, I've got y. So let's make this my y vector. Yeah. My question is, yeah, now I use A, B, C, D. So matrix, now because I'm going to use notation now. So the first row will be something like A1, 1, A1, 2, A2, 1, A2, 2. Okay. Now let me show you what this looks like. Okay. So I use the row index, then column index. This is the opposite of Excel. Excel use column index, then row index. Okay. Here you use row first. So this is 2 by 2. So I'm going to make it more interesting. I'm going to make it 3 by 2. Okay. Now, my question is A dot a x vector plus b x vector, okay, a dot a matrix, okay, this is my matrix, okay. Now, is it the same thing as a matrix dot x vector plus b a matrix dot y vector? Sorry, this has to be y. Okay. So, is it the same thing? Well, let's simplify. Okay, it's the same thing. Okay, just written in a different order. So, it's exactly the same thing. Therefore, we know that multiplying by a matrix in other words, we just solve that matrix multiplication is a linear on. Okay, the generic thing is linear transformation on anything, but we're dealing with vectors. Okay, so in this case, linear something, but we want to work on vector. This is matrix multiplication. Now, this here I wrote AX, but in mathematics it would be something like this. Okay, but in mathematical notation you write like this, and people know. Okay, it's like you don't have to put, you know, the cross sign for multiplication. You put matrix next to a vector, and they know it's that matrix multiplication. So let me write that now. Technically, now also use dot notation. Okay, so that's that. Now, what we have to do is next class, class 5. Start here. Yeah, class 5. Okay. Now I'm going to start with 7. Matrix multiplication to represent system of equation. 8. Solving system of equation. Okay. Now let me do a Google count real quick. I kind of forgot which is better. So let's go. Linear system of equations that gets 1.5 million on the system of linear, which is actually better. Yeah, good. So Google has it right. So people are good because this is technically more correct. System of linear equation. But I've seen it written both ways. Okay, solving using matrix. Okay. And then that's it. And then we'll go to here. Differential. Okay, and then you're ready to do machine learning. Okay, so let me save this. Class 4, side note. And let me share with you this thing or this thing internet. But you need this, right? The mathematics. You want this? Where is that? Mathematics. Yeah, share can be okay. Okay. Now, I'm a little bit too lazy to give you guys a homework, so let's just give you guys a break a little bit. But watch everything I send you, okay? Promise me. Okay, I sent you 3 blue, 1 brown video on calculus. Watch it, please. Question. Question? Okay, good. So yeah, please go and do grocery with mom. Sorry, my apology to your mom.
It's okay ครับ
Okay,ครับ. Okay, so let me ask you. Sorry, big data, right? And let me add that. Okay, right away. So yeah, too late to make a homework now. So sorry to disappoint you, but okay, right? So next week, we'll speed right along. You need a few things from calculus. You know, calculus is this big. You learn just a little bit that you absolutely need. Okay, I'll skip the other bits. Okay, Cap. So I'll see you on Tuesday.
Do we have homework again, please?
No, Cap.
Didn't
No, Cap.
catch.
Sorry. I'm sorry.
Thank you, Hub.
I can make it up by make it extra thick next week, but this week no homework. Sorry about that. Okay, Cap. I'll see you guys, and that's it for today.
Thank you.
Take care ครับ
Take care, Cap.
Thank
Be
you.
safe. Be very safe. อย่าประมาทลูกอย่าประมาท
Thank you ครับ
โอเคครับ
สวัสดีครับ
Thank you.